mechatronics engineering program in undergraduate level, and this time we are going to start a new program, be in robotics and artificial intelligence. So Professor Ajayinder, he's the Deputy Director. He has already explained about the institute. I am the professor and head of the department. And if you introduce Professor Jawanda. Okay, Professor Jawanda, he's associate professor and he's specialized in CAD CAM. So this institute was established in 1956, and at that time, our mechanical engineering program also started in the same year. And this mechatronics engineering, this was started in 2012, and this mechanical engineering program is both NBA and ABET accredited. And this mechatronics is NBA accredited and eligible to apply for ABET. And this year we are going to start robotics and AI of SET 60. We have 2 postgraduate programs. Now, if I see the title of this webinar, and from this picture, it is very much clear. If you see 2021 digital transformation assessment, and it was given by IBM, that cybersecurity, advanced data analytics, cloud computing, this is the advancement 88.79%. And if you see the 4th one, automation and robotics and IoT or AI, artificial intelligence, you see the growth may be 75% around. That's why we are interested to start this new program of robotics and AI because for all the mechanical systems, if we introduce with this automation and artificial intelligence, and in that case, the productivity can be enhanced and the safety can be also enhanced. That is the prime objective. Now, if you see 3 broad areas for mechanical engineering, all of you know design, thermal, and the manufacturing. But now the new things, it was started from 2000 onwards. We have studied another subject that is called control, instrumentation, and robotics that we have started in mechanical engineering. Okay. But if you see for the mechatronics engineering, all the subjects of mechanical remain same, along with some few new subjects were introduced: artificial intelligence, data structure, image processing, and machine learning, etc. Similarly, for robotics and AI, so data science, Python programming, these are the subjects required, applied artificial intelligence, and of course, robots, its sensors, actuators, and control systems. Now, there are 3 broad categories or the focused elective areas in mechanical, that is automotive technologies, robotics, and smart manufacturing. So if any student want to opt, suppose all the 3 subjects of automotive technologies, then a certificate from the department will be issued along with the B certificate from the university. So in our department, we have 53 faculty members. Out of 80% faculty, they have done their PhD either from IITs or from abroad. And we publish 90 SCI papers per year, and we have more than 10 crore rupees of projects. So all the faculty members are involved with the research very much. So if I say the job prospects of mechanical engineering along with mechatronics and robotics, these are the areas that is given here. The main areas is automotive sectors or design, or if it is the thermal, renewable energy, or if it is heavy engineering or refrigeration, air conditioning. So this is the conventional areas along with the robotics, mechatronics area, automation, those things for those robotics engineer or the mechatronics engineer is required. Now, this is the first time in India that Thapar Institute, we have started our project semester. This is of 6-month duration. All the students stay in the industry for industry fit. Currently, our third year students, they are in industry and they are staying from January to June, and they are learning all the industrial aspect because they will be fit before joining in industry. So we have very good contact with the different industries in India as well as abroad. So we have very good contact with the industry connect. Now, if I say this is a very important slide, up to 22, this 23 this year, up to April, almost 78 companies visited, and this placement will continue up to December. And I think this year we will almost 150 companies will be here in Thapar to absorb to recruit mechanical students. And if you say this year up to 23 April, our highest package is 40.9 lakhs per. Okay. So this is the highest package this year. So it is gradually increasing. Now, if you see the placement this year, total student, eligible student is 277. And out of 222 students were already placed up to April. And I believe you see here, almost 80% students were placed. And before pandemic, if you see before 2018, 17 or 16, our all 92% or 93% students were placed. And due to pandemic or slowdown of the industries, this was of course below the 90%, but this time it will be around 95% that I believe, because this will continue up to December. Now, these are very famous alumni. And if I say Mr. Rajesh Uppal, he is the IT and education training, Maruti Suzuki. Or if I say another, Mr. Atul Sodh, he is the Deputy General Manager of Toyota. So each and every industry in India or abroad, so our alumni are placed in a good position. Or if you say Mr. Atul Jaggi, he is the Deputy Managing Director of Gabriel. Okay, so I've given the few list here. So we have very sophisticated labs, and all the labs are very world class, and all the equipments are basically very sophisticated and new. And we have around 25 labs for the undergraduate, postgraduate, and research level. And if you see, this is the central workshop. I think this is the first in India we train all the students in the CNC lab. I think there are around more than 15 machines are there, and all the students are, that is CNC milling, CNC lathe, everything is available. Now you say very small group of students are in a group are basically trained using these CNC machines. Of course, we have the conventional systems, and those are used by our diploma students. And these are some conventional machines and also CNC machines. We have also the industrial CNC level CNC machines. This is very advanced lab, additive manufacturing lab. So this is the basically future, you can say, and we have many more machines for additive manufacturing. Now this is advanced metrology lab. This is heat and mass transfer lab. This is very sophisticated lab. This is the conventional automobile lab. And this is machine tool lab. Just I am showing the name. This is IC engine, different types of engines, petrol, dual, and then diesel, then hybrid, different types of engines are available. This is almost industry inside the institute. This is the basically given this money by NTPC. This is the pneumatic conveying lab. So I'm intelligence. You know, the mechatronics engineering, basically this is the synergistic combination of all mechanical, electronics, electrical, and computer engineering. Okay, and this was started long back in India, and from 1992 onwards, when we opened our market to enter the global companies in India. Now in robotics and AI, basically this is of course part of mechatronics engineering, but the main emphasis is given in the area of robotics, industry 4.0, automotive engineering, and smart manufacturing. Okay, and the purpose of robotics and AI is to basically to automate tasks, improve productivity, enhance the safety, and of course, enable data-driven decision making and innovation. Now, if you say, so these are the very few, I've given the very few list where the students can be absorbed who will take these two departments, that is robotics and AI. So these are the pioneering company in India and world. And you see, for the mechatronics engineering, the students will study all the basics of design engineering, basically, then control systems, then data acquisition, and also the modeling simulation, and finally, this machine learning and the artificial intelligence. Okay, so these are the purpose for the basically strong base of engineering, then design, then microcontroller development, then also some projects. So if I see here, all the subjects I've given in mechatronics engineering, all the blue color, these subjects are taken from mechanical engineering, and all this that is gray color subjects are from computer engineering, that is computer programming, artificial intelligence, machine learning, image processing, and some subjects from electrical engineering, that is sensors, actuators, signal systems, and also some subjects from electronic engineering, and that is the power electronics microcontroller. So basically the 50% subjects were taken almost from mechanical, and rest of the 50% subjects from different, because this is the combination of 4 departments, 4 areas basically. And if I see the difference here between the mechatronics and the robotics and artificial intelligence, you say all the black font, these are subjects same of mechatronics engineering. And we have introduced some subjects of robotics. You see almost, I think 9 subjects, that is almost 35% subjects from robotics area and almost 15% from artificial intelligence. That means almost 50% from robotics and AI, and rest of the subjects from basically the automation and the basics of mechatronic systems. And just I will show you the basic labs of mechatronics. You can see here the different labs of mechatronics engineering, the control system lab, IoT lab, electronics and automation labs of computing, and there are different many more labs. So I request Professor Jawanda to start.
Thank you, Professor Bera. So these are the snapshots of those laboratories. Then we also have the projects which the students deal with. Now, Dr. Batish had started you off on a little bit of an introduction to what are projects and the value of that in modern technical education. I will take a little further that education in India was traditionally more classroom-based, laboratory-based, and the kind of laboratories which you have all done, even in +2, require that you have a similar result to what is intended in the laboratory file. So everyone will have an experience of going through those experiments. What is required in the real world is that you have to be innovators. You have to take on different projects, and those projects may not have been done by anyone in the past. That's what creativity is, what is required for. So to make the students learn how to be creative, to have the options of different kind of concepts to be analyzed, we introduce them to projects right from the first year. This is one of those projects which is shown here, which we had I had gone to Trinity College in Dublin in the year 2015 and learned what is the project behind this, and then reintroduced it in Thapar. And this is one of the reasons that our curriculums are harmonized with many of the universities in the Western world and the advanced world. So the Mangonel project, as you can see here, is a combination of mechanical as well as electronics. And the students are able to use both these knowledge in a project, which we have even competitions. You can see some pictures over there. Students are actually getting to fire what they have assembled. The small disassembled one you can see in a picture is what they assemble and make in the process, learning how designs are done, as well as how to make their own designs. And when you come here, of course, we will show you how all these innovations are done. And even presentations of those in the kind of a poster which is shown here, just as an example on the lower right side. Next. Now, going forward with project-based learning, we have also been the unique university in India to launch what is the experiential learning. Experiential learning is different from just experiencing it in a laboratory. This is actually bringing what is real world engineering to the students. So we start with bicycle dissection, where the students, you can see in a small picture on the top, dissecting a bicycle, reassembling it, learning how the engineering in all the components is actually done, and how the design of a bicycle has evolved over time, over centuries, as well as how it is proceeding further, and we can make the bicycle even better. So we start with this in the very first semester. Second semester, we introduce you to something like an IC engine, even transmission system of an automobile, and learn what is the engineering behind those things. And then there are projects which we are going to associate with these engineered products in different courses, link them to the real world so that you know what an engineer is going to be doing in the jobs in the industry. We have similarly given challenges to students, very successfully done in the third semester itself, of building a complete machine for chair testing. We also have for the 2-axis and 3-axis CNC, or computer numerical control machines. So this is the stage in the fourth semester itself. We introduce the students to what are the control systems behind the machines, as well as in robotics, and how do we actually do controls using programming. So there is going to be a lot of learning from different branches, which will come into mechanical field over here. Of course, mechatronics will be introduced in a slightly different way or two, but mechanical too now requires basic electronics, basic computing to make things function. Even our household devices, as you can see, are now programmable, even though they may be mechanical devices. So the last one over here is also a heat exchanger, which is a design to understand how engineering with a lot of ingenuity behind it is done, and then we can even test what is the results of each and every group of students doing something differently. Next one. So the final year, we have what is a trained student, and we want to demonstrate what you have learned in the engineering. And the kind of projects which you're seeing in front of you, these are the CAD models of those made by the students. And we have every year a team of mentors from the faculty who is going to be taking you to the process by which anything is done, even in the industry. So starting from customer needs to making an innovative product, which doesn't exist. It has to be customized to the customer requirements. So these are the kind of examples you can see, which is a solar concentrator, a automatic lawnmower, a 3-axis machine. We have all-terrain vehicles, some robotics. We'll have wheelchairs, which are for different purposes, and redesigning those simple things like wheelchairs also in a manner which is going to solve certain needs of patients, which ordinary wheelchairs do not. Here is a vehicle which is for patients, which is very innovatively made on the top, where those who cannot walk are able to actually transport themselves, and even do daily needs very easily. This is a video of a trash collecting system. It is, of course, designed by the students, and it is manufactured also completely within the department. And you can see multiple of these. So this year we had about 66 projects of this kind. We cannot show you all of them over here, but this is just a highlight of a few things which they have been able to do. We also have projects which are done in laboratories, which are guided by research which is going on. So this is a 3D printing equivalent of using welding for it. So metallic 3D printing machines, of course, have been developed, but we are also going for our own innovative ways of making products which will have a layered technology of building from scratch. This is an exoskeleton, which is for assisting not only those who are injured, but sometimes even those who need to have an excessive power requirement, which a body cannot sustain. These are examples of 3D printing. We have a full laboratory, and we are going to soon be adding a metallic 3D printing to that also. This is a sculpturing for woodworking and metallic parts, which is unique in the whole of the country. This one, again, you can see some examples of wood carving, which is done using the computerized machines at the bottom. This typically will take a lot of time doing manually, and to repeat these things is, of course, going to be a problem unless you have a machine. These are, again, projects which are done by students, which are robotic arms of different kinds, some rovers and even aerial vehicles for different terrains. We also have some examples of students making things which go on water and underwater. So depending on the customer requirements, this is a robotic device which is, of course, made for the shop floor. So it is going to follow a line. These are the kind of technologies used on shop floors for automatic transfer of materials and automated guided vehicles. So this is where research and the classroom teaching also will merge. We have also got a lot of student activities. So as you can see, these projects, which we have just shown you, are the precursor. It opens up the confidence of the students to actually do things meaningful in the world. And we are proud to show you that the students are able to perform at a world stage. They have been able to learn these things and demonstrate making even Formula One cars. So this is examples of our students of Team Fateh who have gone and brought laurels since the year 2008. And we also have the society which is working on the rovers, which is for robotics and automation. So Team Fateh, a little more details for the latest achievements. So this was in Gautam Buddha, January in the circuit over there. So we, our team stood first in the overall stats of events. Engineering design was first in India, cost and manufacturing first, business presentation was third. But as you can see here, and in the, you can see a video also before they went for this, how they test the vehicle. So that is exciting for us to even see every year when they practice late at night so that the noise doesn't, of course, disturb the classes during the day, and that is done in the campus. This is a team which had gone for the rover challenge, and they had done an excellent job of securing the 6th position, and they'd gone for the first time amongst 35 teams. And more than 700 students from different parts of the world took part in this. And this is a feature, again, which is a student team. The students are working in a way that will build their confidence for making products of the same kind when they go to industry. Now, we also teach the students through these projects, not only to be prepared for the industry, but also to set up your own industries, to be innovative enough to solve the problems of the society, and you can become an entrepreneur. And we have collaborated with one of the best institutions in the world, with Professor Ard, who is a world leader from the University of Groningen in Holland. And 20 of our faculty members have gone and trained over there under him, and are running a common course for all the branches, which is on innovation and entrepreneurship. And we have a separate center, which also is for incubating these startups. And we are having a number of these supported from Government of India grants. We have got a few crores in the past few years for supporting such startups within Thapar itself. This is how we have been able to give to the community. We, of course, have many of our students going into the community and helping out otherwise. But this was for making products during the COVID emergency, that we required ventilators which were in short supply. So our team over here in experiential learning also stepped up. We made these ambu bag compression machines with using different technologies, electronics, pneumatic, hydraulic, and this was appreciated to the extent that the Government of India, and especially the PGI in Chandigarh, collaborated with us, and we have supplied them with many of the equipments. You can see the next slide, for providing them with robots of this kind, which will be used on the hospital floors, and where the doctors and nurses want to remain safe, they could send these rovers with the medicines, and they had a communication medium also with the help of the community at that time by making face masks and shields, so that people feel safe. Even in the front lines, these police needed this protection. So now we have learned from the pandemic. We have all come out of it, but we have got good learnings from it. So one of these is that we always had continuation of classes. They were never disrupted in Thapar. We adopted technology within a week, so that our students back at home were back into classes. And we have got digital technology implemented since then, to the extent that now all our courses have e-content. They're accessible to students. We have got video lectures, just like NPTEL by the central government. We are, of course, able to conduct many evaluations online, and have the administration of many of our courses also, which is in an online mode. So with this, of course, I will conclude. And if we have a little time, we can show you one or two videos which will show you and showcase what our students have been doing.